Certain so-called paramagnetic substances have small local magnetic fields which cause a shortening of the relaxation times of the surrounding protons. This effect is named proton relaxation enhancement. The body contains paramagnetic substances under normal circumstances. Examples are degradation products of hemoglobin, for example, deoxyglobin and methemoglobin, which are found in hematomas, or also molecular oxygen. Gadolinium, a paramagnetic substance, is used as an MR contrast medium, marketed as Magnavist. Chemically, the substance is a rare earth. As gadolinium is toxic in its free state, it is bound to DTPA in a certain way called chelation, which solves the problem of toxicity. The pharmacological properties of gadolinium DTPA are very similar to the ones of contrast media in conventional radiology. Gadolinium DTPA, however, is even better tolerated. The contrast medium has an effect on both the signal intensity of T1 and T2. They shorten the T1 and the T2 of their surroundings, meaning that the respective curves are shifted towards the left. In effect, for a certain TR, there is more signal. For a certain TE, there is less signal. In this figure, the signal intensity for two tissues, A and B, is illustrated. The IV-administered gadolinium DTPA enters tissue A, but not tissue B. The T1 of tissue A becomes shorter, and the T1 curve is shifted to the left. The result is that the signal from tissue A at time TR is stronger than it was before, and the two tissues can be better differentiated because there is better contrast. What happens when we perform a T2 weighted examination after contrast medium application? These are the T2 curves of tissue A and B. As we have just heard, the contrast medium shortens T2 of tissue A, which is entered by the contrast medium, shifting the T2 curve to the left. Now, there is less signal coming from tissue A. Loss of signal is often more difficult to appreciate than a signal enhancement, as we have just seen. This is why T1 weighted images are the predominant imaging technique used after contrast medium injection. As the substance is not distributed evenly throughout the body, signals from different tissues will also be influenced differently. Vascularized tumor tissues are enhanced, for example. It is also important that the gadolinium does not go through the intact, but rather the disrupted blood-brain barrier. It has been shown that the use of contrast media improved lesion detection and diagnostic accuracy of MRI. It may, for example, help with differentiation between tumor tissue and surrounding edema, which might be otherwise indistinguishable. Gadolinium DTPA entering into the tumor tissue shortens the T1, thus making the tumor bright in a T1 weighted image, while the surrounding edema may not be influenced at all. there is another beneficial effect caused by contrast media. As we've already seen, gadolinium DTPA shortens T1. Thus, we are able to shorten TR in our examination. And because imaging time depends on TR, as we will see later, imaging then may take less time.